Alright, so in this video we go over section 8.2, systems of linear equations by matrices. So in this section we are going to use a slightly different method than the ones that we covered on the previous video. So we're going to represent systems of equations by means of a rectangular array of numbers called matrices, so which is the definition. So a matrix, it's going to look like this sometimes. With brackets or sometimes with big parentheses, depending on the textbook that you read, depending on the source that you run into. And well, matrices are defined by their size, and in this case their size is m by n, and in this case the order matters in this case. So m is the number of rows. We state the number of rows first, and then n is the number of columns. So we have a few matrices here. Let's determine the size of the matrix. Sometimes they call them the dimension of the matrix. Well, we're going to call them the size. So letter A, I claim this matrix is 3 by 4 because we have 3 rows. That's 1, 2, 3, and 4 columns. 1, 2, 3, 4. Okay. And then letter B, well, we have a 4 by 3 because we have 1, 2, 3, 4 rows and 1, 2, 3 columns. Letter D, which is only one, it's only one row. It's one row by, well, it's going to have 1, 2, 3, 4, 5, 6, 7, 8 columns. In letter E, it's going to have 1, 2, 3, 4, 5 rows, but only one column. Okay, so again, order, it's going to matter. Rows first and then columns. Rows first, then columns. Alright, that's the key here. Alright, so now we're going to look at another definition. The next definition is augmented matrices. So an augmented matrix is a special kind of matrix that is used to represent a system of equations. Alright, so for example, if we had a 2 by 2 system of equation, a1x plus b1y equals d1, and the equation to a2x plus 2a2y equals d2, well, we can represent, this actually must have been a b, okay, not an a. And so we can represent this as an augmented matrix. All we do is pretty much copy the coefficients of the variables a and x and y without the letters x and y. This little bar here, which denotes that this is an augmented matrix, it's representing the equal signs, and this d1 and d2, it's the column that represents the constant terms. So as a whole, these are augmented matrices. However, and you might see this on different questions, the matrix that lies before the bar, it's called the coefficient matrix, which is this guy right here. And it's the same for a 3 by 3 case or for a 4 by 4 case, all right? So before solving this, let's briefly, look at some examples. Well, so we have the system of equation. They're asking us to represent this using an augmented matrix. So what are we going to do here? Well, all I'm going to do is write the numbers along with their signs. 3, -4, and 4. 5, 2, and 11. And well, the 4 and 11 are the, the constant terms. Okay, so what are we doing here? What we do is we're given a system of equations and we are going to encode it into a matrix. Let's do another example. So we have a system of 3 equations with 3 unknowns. Well, number 1, notice this system needs some work before we can do anything. So this system, be sure to have all variable terms on one side. Okay, so this y right here, it's on the right hand side of the equation. I need to move it to the other side with the opposite sign. And same this negative 4c, I need to move it to this side. Okay, and I'm going to have the following. I'm going to have, well, the first equation rather remains the same, 2x plus 3y minus z equals to 4. And then I'm going to have 4x minus y equals to 9. Keep in mind that there's nothing here. Okay, that's 0z if you will. Over here I'm going to have 3y plus 4z equals to 0 essentially. And here we have a 0 in the coefficient of x. So if we encode this into a system of equations, into a matrix rather, we're going to have 2, 3, negative 1, which corresponds to each of the coefficients of each variable, and then the bar for the augmented matrix, and then the constant term. Then I'm going to have 4, negative 1. Keep in mind there's nothing. There's a 0, 4, negative 1, 0, and the 9. Then keep in mind there's another 0, 3, 4, and then another 0. And that's our encoded system of equations into a matrix. Now we're going to do the reverse because, of course, we are going to do operations with matrices, and then we are going to go back to system of equation notation. So in this case, we're given a matrix. We are going to decode the matrix into a system of equations. Essentially, what we're doing is getting rid of the brackets here and the little bar that means equal sign, and putting the letters x, y, z, x, y, z, x, y, z. That's all we're doing essentially. That's 4x plus 2y plus z equals negative 3. This 0 is not going to give me anything for x, so I'm just going to go to 5y plus 2, z equals 1. And then, again, another 4x minus y minus 3, z equals to 0. Okay, and that's our decoded system. All right, so let's see what's next. What's on the next page? So on the next page we're going to use our graphing calculator. The method to actually do this and do it by hand is very tedious. So in this video, I'm going to show you how to use matrices in your graphing calculator to solve this system of equations. Okay. So I'm going to show you my calculator here, and I'm going to go and so first of all, we need to encode this system into a matrix. So 2, negative 4, negative 3, 1, bar, negative 30, and then 20. All right? And we need to know what the size of this matrix is in order to be able to do it in the calculator. Notice there are 2 rows and there are 3 columns. All right? That's a key here. That's a very key point. Okay, so what are we going to do here? So we are going to we're going to click second, and then the x to the negative 1 to reach matrix. Okay, and in this case, well, if you already have some matrices, for some reason you used it already, have done this already, we're going to scroll all the way to the right and highlight the edit, because that's what we are going to put the values. So it's a 2 by 3 that I got it already. Okay, and I'm going to put these numbers: 2, enter, -3, enter, -30, enter, -4, 1, and 20. Okay, so I'm done editing the matrix. What I'm going to do, I'm going to hit second and mode to quit. And then I'm going to go back to matrix, second matrix. And in this case, I'm going to choose a math operation. I'm going to do math. And I'm going to scroll down a few times until I get RREF. Notice I'm not using the ref, but the RREF, the one with the 2 R's. Okay, so that's the operation I'm going to do on a matrix. What matrix is that? Need to go back second, matrix, and choose the matrix you want to do the operations on. In this case, the matrix A, in which we have all that information. Just click, not under edit, click under names. And then close parentheses, and boom, that's going to give you the reduce system. So I'm going to write this as a final answer. So what's the notation that you need to this arrow, RREF, and then that's a 1. Okay, what did we obtain? This RREF, this means reduced row echelon form. Reduced row echelon form in the means of the main diagonal. Here, this matrix has only once as a main diagonal, and it looks like a staircase. That's why we call it the echelon form. Now, when we decode this matrix into a system, this is going to be our X, and this is going to be our Y. But why in this case? Well, how come that happens? Well, decode this into, that's X plus 0y equals -3, and 0x plus y equals 8, which, if we get rid of the zeros, this is just going to give us x equals -3 and y equals 8. And by the way, write this using order pair notation. All right. So that's our first example. Our second example, letter B. Well, let's do a 3 by 3 system now. Okay, so I'm gonna go second matrix. I'm gonna edit a matrix, but well, the good thing is, well, first of all, I need to encode this into a matrix first of all, before we can do the calculator part. So that's gonna be a 1, 3, -5/3 bar and -2/3. 2, -3, -5/3, 1. 2/3, 1, 5, 1. All right, so what are we going to do here? RREF on that matrix. So first of all, let's edit our matrix using our graphing calculator. So I'm going to edit in this case, it's 3 rows by 1, 2, 3, 4 column. It's a 3 by 4 this time. So edit and ignore these numbers. Okay, those are from a different class. So I'm going to type 1, 3, -5/3. Notice it's going to turn everything into a decimals. At the end, we're going to change everything to fractions back again, and then -2/3, -2/3, 2, -3, -5/3, and 1. That's 2/3. 1, 5, and 1. Alright, so I'm going to quit again. I'm going to do second matrix back again, and then I'm going to go to math, scroll down a few times until you reach the RREF. And then I'm going to go again to second matrix to choose under names. In this case, I'm going to choose the second matrix. I'm going to close parentheses and click enter. And look at this, you're going to get that as decimals, but when you are doing this, especially when you are doing the homework, it's not going to accept decimals. So in order to fix this, you are going to click math, and then the first function that is highlighted is the frac command. Click on it, answer frac, and click enter again. And that's going to give you the reduced matrix. So in this case, the reduced row echelon form is going to be 1 0 0 0 1 0 0 0 1 bar 1/3, negative 2/9, 1/5. All right. So look at the main diagonal. The main diagonal is comprised of all ones only. That's the echelon. That's the staircase of ones. So in this case, when we decode this system, well, I'm not going to do the 0x and 0y at this point. Hopefully it's clear that these zeros do not put anything. So this is going to be x equals 1/3, y equals negative 2/9, and z equals 1/5. As another triple in this case, 1/3, comma, negative 2/9, and 1/5. Okay, so that's our solution to this system of equations. All right, let's do another example. Let's see. Let's keep practicing on this. The more we practice, the better. So I'm going to go second matrix. I'm going to edit the matrix in this case. Well, first of all, I need to write a matrix, right? So let's see. I'm going to have 1, 1, 1, negative 3. 1, 1, 1, negative 3. There is a bar here. 2, negative 2, negative 1, negative 7. Negative 3, 1, 5. And another 5. So we're going to do RREF. I'm going to have, well, I don't know what am I going to have. So I wouldn't just assume that I'm going to have a ones along the main diagonal. That's not going to be always the case. I'll show you in some examples. So let's edit the matrix. I'm going to do, well, suppose you don't have a matrix already. You type the 3 rows and the 4 columns. And let's start typing the numbers. 1, 1, 1, negative 3. 2, negative 2, negative 1, negative 7. Negative 3, 1, 5, 5. Second quit. Second matrix, I'm going to do a math operation on that matrix that I just edited, which in this case is RREF. So RREF on the matrix. Oh, there's 2 3x4s in this case. Let me see. I don't think I can delete this, so I'm gonna do the letter A, and that's what I'm going to obtain. All right. Yes, it's a row. It's an echelon of all ones. It's a main diagonal of ones. And negative 3, 1, and negative 1. Decoding the matrix into a system of equations, we get x equals negative 3, y equals to 1, and z equals to negative 1. But of course, we need to express this as an order triple, in which I'm going to have -3, 1, and -1. Final answer. All right, let's keep moving, doing more examples here. Okay, so let's do the last couple of examples. So we have a different matrix here. So a different system of equations. Let's encode this system into a matrix. 1, 2, -1, 4. -2, 3, 1, -4. 1, 9, -2, and 1. All right. Let's do RREF and see what we are going to obtain. I don't know what am I going to obtain here. Sometimes get a little bit tricky, and you don't want to be tricked about those weird things before you can type anything. So first, second matrix. I'm going to edit matrix A. They're both 3 by 4, notice. But I'm going to edit letter A again. And I'm going to put these numbers. I'm going to put these entries. 1, 2, -1, 4, -2, 3, 1, -4, 1, 9, -2, and 1. That's 1. Okay. Let me double check. Yes, everything's fine. 2, 3, 1, 8, 4, 1, 9, -2, 1. Second matrix, I'm going to do a math operation, which is RREF. On the matrix A, which is the one I edited, choose it by name. And we're going to get something very weird. First of all, let me math frac command. Okay, I'm going to show you the weirdness here. I'm going to show you where's the weirdness going on. So that's a 1, 0, 0, 0, 0, 0, actually 0, 1, 0, -5 sevenths, -1 seventh, 0 bar, and then 0, 0, 1. Okay, pay special attention to this system of equations. As opposed to the previous systems, we got really nice solutions. However, pay special attention to this last row. This is telling us that 0x plus 0y plus 0z equals to 1, isn't it? But this whole left-hand side of the equation is telling us 0, this equal sign, and 1. Isn't this a contradiction? For this reason, this system is no solution. No solution to this system. All right. All right, so let's look at letter E. Letter E. Second matrix, and I'm going to edit the same one, A, matrix A, with the matrix that I'm going to encode this system into. So this is going to be 1, -3, -1, and 4. 1, -2, 2, and 5. 2, -5, 1, and then 9. Okay, so I'm gonna do some RREF. Okay, let's put this into the matrix. It's in these entries into the matrix. So that, okay, the 1 is already there. 1, -3, -1, 4, 1, -2, 2, 5, and then 2, -5, 1, 9. second quit, second matrix, I'm going to do RREF on this same matrix. I'm going to choose a second matrix, choose it by name. And we're going to get this interesting thing. All right. Let's see what we got here. This is another special case. So 1, 0, 8, 7, 0, 1, 3, 1. And all zeros along the last row. Okay. Now, what is this going to mean? Well, notice that if we go back to the other systems of equation that we did earlier, that we did on the previous pages, the last row decodes the z's. The second row, it's going to decode. The second row decodes the y's. And I need a different color here, orange. The first row decodes the x's, okay? But the weird thing about this, this last example is, well, what is this last row telling us? Well, this is essentially telling us that 0 equals to 0, but notice this comes from the third row, the one that decodes the z's. Okay, let me take a break from this and let's go back to logical operators. Remember, if you have the statement x equals to 3, so you might remember that you can do whatever you want on an equation as long as you do it on both sides of the equation. For example, multiply by 2 on one side as long as you multiply by 2 on the other side. That's a 2x equals to 6. You have x equals 3. For example, I'm going to add 2 to both sides to get x plus 2 equals to 5. I'm going to have, what if I add the letter z? I can add the letter z if I want. And that's going to read like x plus z equals z plus 3. Again, as long as you do this operation on both sides of the equation, well, over on both sides of this statement, well, it should be right. So that's what I'm going to do here. So in this case, I'm going to add z to both sides. So z equals to z. So that's our first solution. I will explain what about this in a moment. For the second row, what are we going to have? I'm going to have x plus 3y equals 1. Okay, not x plus y, it's actually y plus 3, z equals to 1. Okay, so in this case, I'm going to solve for y. Okay, so y equals 1 minus 3z. Okay, so in this case, well, I'll show you in a minute. Let me do the first row, which is the other solution. That's x plus 0y plus 8z equals to 7. That is x plus 8z equals to 7. I'm going to solve for x to get x by itself. That's 7 minus 8z. So in this case, what do we have here? So as opposed to the previous one that we had a no solution, this is an infinitely many solutions of the following form. Those infinitely many solutions are going to be expressed of this form. Curly braces, all the order triples, such that, well, in this case, x equals 7 minus 8, z, y equals 1 minus 3, z and z equals to z. And typically they add that z belongs to all the real numbers. It can be any real number. So this is one case of this of every single type of example for solving equations using the graphing calculator. We have the no solution case as well. How to identify? Well, when you have one row with all zeros on the left hand side or on the coefficient side of the matrix, and a number on the independent term column. Okay, that goes into 0 equals a number. Well, that's a contradiction. That's a no solution. But when you have a row of all zeros, you need to be very careful about those. All right, because that's in the first place, decode the third row of all zeros as 0 equals 0, which is z equal to z. Remember, we go in a way back substituting in backwards alphabetic order. We do the z first, and then the y, and finally the z. And we express it in this form. You'll see when you see it in the MyMathLab homework exercises. Alright, so this is a good moment to quit, so I'll see you on the next video.